right. All right, can everybody take a look at the handout sheet now? And I can tell you right now that tests are not why I want you to learn it. I don't want you to learn it because of the test, but on the other hand, what is it you think I might ask on a test? How do I know that you're learning something? So that's why I give you tests. Now, we'll have homework too. We have homework things, we'll have tests. But what I'm going to do is, the next test we do, there's about 12 vocabulary words I'd like you to learn, and they're not that hard. So let's take a look at page number 1 and see how many we can come up with. First of all, chemical reactions. In this chapter, we're going to talk about how chemicals react with each other, and you're going to learn how to classify. What kind of a reaction are you? Number 2, you're going to learn how to balance a chemical equation. A lot of you are going to enjoy that. It's like a little puzzle. Predict what's going to happen in a reaction, and then identify these things called driving forces. So that's what my goal is for this one. So let's start back way long time ago, near the beginning of the year. What did we call this right here? These things you saw on the periodic table, what did we call those? That they represent elements, but what did we call AU or Na? Chemical what? What were they called? If somebody said, what is ZR? It's a chemical what? Symbol. And we learned those a long time ago. You had a quiz on it. Remember that? I give you the name, you give me the symbol. I give you the symbol, you give me the name. All right, those are called chemical symbols. But every time I write AU, what does it stand for? It stands for the element gold, doesn't it? It stands for the element or an atom of gold. Then we had another chapter, the last chapter. What is this right here? What do you call NaCl? Chemical formula. And didn't we learn how to write formulas? Okay, now what's this chapter about? This chapter is about this thing right here. Now that looks a little bigger than those other two, but what do you call that? Chemical what? Equation. So there's the first 3 vocabulary words that might be on there, and they said, I think I can get this. Well, let's take a look at equation. Let's see what it looks like. This right here looks like a different language, doesn't it? And if I were taking a foreign language, wouldn't I have to maybe in my mind translate it? If I saw something in French, it says, j'entre dans la salle de classe. I entered into the room. I'd have to translate that, wouldn't I? Do you know French? Oh, I didn't say it that greatly. J'entre dans la salle de classe. How do you say it? Can you say it in French?
I don't understand what.
Oh, j'entre dans la salle de classe. How do you say I entered into the room?
J'entre dans la classe.
One more time?
J'entre dans la classe.
Okay. What about je prends ma place? Je prends ma place.
Je prends ma place.
Okay, so you took your seat, right? Okay. Je vois les élèves. What's that?
I see the students.
Okay. All right. That's very good. So how many languages do you know?
3.
Wow. Impressive. Okay. Well, anyway, let's take a look. This is kind of another language. I'm going to call it Chemonese. And so what we do is with any language, we might have to translate it. And so let's take a look at this. I'm going to say this in English. Ready? Zinc reacts with hydrochloric acid to produce zinc chloride and hydrogen gas. Now that's what I eventually want you to be able to do, is to translate chemistry into English, English into Chemonese. All right, now let's take a look at this. I'm going to show you something. You see this little arrow? Everybody see that? And notice that these things are on the left side of the arrow, and these are on the right. Okay, what do you call the things on the left side of a chemical equation? Reactants. Okay, ready? Another vocabulary word. What are reactants? Those are chemicals that are going to react. Well, this is easy, isn't it? Isn't this easy? Okay, now, what do you call the things on the right side of the arrow? And all you have to do is look at the paper. Products. Guess why they're called products? Because those are things that are going to be Say it. They're going to be produced. No wonder they call them products. They're going to be produced. So when I say look at the reactants, you look on the left side. Find the products, you look on the right. Everybody got that? This is basic vocabulary for chemistry. This is the next one. Products are chemicals that are produced in a chemical reaction. They're found on the right side of the arrow. Now, you might see some additional symbols. If you see an S after this, it means it's zinc in the form of what? What does the little S mean? It's a solid. And we actually have that back here. I have some zinc. You're going to do this experiment. You're going to take solid zinc and you're going to put it into, and what does AQ mean? And by the way, I made a mistake here. It's supposed to be little a, little q. It's not capital, sorry. That was a typo. I should have fixed it. What does AQ mean? Dissolved in water. Now, guess what? It'll look like water. This is going to look like water. But it says hydrochloric acid on it. So solid zinc reacts with a solution of hydrochloric acid solution, and produces, what does this say? What's that going to look like? What's zinc chloride aqueous going to look like? It's going to look like water. Who said that? That was right. Because it's dissolved. It's dissolved in water, and I won't see it. I won't see it. And what else is produced? What's that little G mean? Gas? I'll see bubbles. I'm going to see bubbles, aren't I? And when you do that experiment, we're going to test those bubbles. And it's kind of neat because those bubbles are hydrogen. Do you know anything about hydrogen we found out from the video yesterday? Wait, did we watch the video yesterday? Yeah. What do you find out about hydrogen? What do you know about hydrogen? Is it flammable? And that's what you're going to do. You're going to make a little bit of hydrogen. You're going to stick a stick in there, and it's going to, boom, it's going to explode. You're going to have a little mini explosion, and you're going to prove that that gas was hydrogen gas. Got that? It's called a pop test. A pop test is a little mini explosion of hydrogen gas. You don't want to make a lot of hydrogen gas. It'll really explode, won't it? Remember that bathtub? That was a lot of hydrogen gas that got caught on fire. It exploded. All right, what about this arrow? What's the arrow mean? Help me out here, okay? Zach, I bet you had that. You had to have the arrow. Did they talk about chemical equations? Did you have chemical reactions? Okay. Anybody? You had this in middle school, didn't you? What's the arrow stand for? Yeah, it means yields, which is a fancy way. I don't know what that means. What's yield means? It means makes, produces, forms. Get it? And that's what it means, all right? Another thing I want to mention to you about the arrow is it's kind of like time. If I'm on this side of the arrow, nothing's happened. Nothing's happened yet. What about the other side of the arrow? See? Before the reaction took place, and what is this? What's after the arrow? Isn't that after the reaction took place? Yes? Okay, that's another thing, the arrow's there. Now, sometimes in chemistry, and even in biology, you'll see things written on top of the arrow. I didn't have very much space here, but do you remember in biology class when they're doing photosynthesis? And maybe you saw the word chlorophyll or light here. Did you see that? It was written on the arrow. That means I'm not a reactant, and I'm not a product, but you have to have me. I have to have light for photosynthesis, don't I? Is light a chemical? No, so it's not a reactant. Is it a product? No, but I had to have light, didn't I? What's that green stuff in plants that you have to have? Chlorophyll. It's not a reactant. What happens to chlorophyll? It gets excited. It gets excited. Electrons get excited, and they come back down. They get excited again. And that's all. I need chlorophyll to do that, to capture that energy. But it's not a reactant or a product, and so you put that on top of the arrow like that. All right. Now, the last thing I'm going to do is this right here. Why is it called an equation? Why is it called a chemical equation? What's equal? What's equal? And that's what I want to think about. The word equation means something equals something, doesn't it? I want you to take a look at this and tell me if it makes sense to you, okay? I'm going to go up here, and I'm going to try to draw this in a cartoon fashion, okay? This says zinc, so I'm just going to draw a little circle that means zinc. Reacts with hydrochloric acid. Okay, I think I'll make the H part of hydrochloric acid look like that, and I'll make the Cl part look like that. Everybody see that? And it says Zn plus HCl yields ZnCl2. Wait a minute. You said ZnCl2. How can that happen? How many hearts did I start with? How many hearts did you start with? How many Cls did you start with? Well, how'd you end up with? How'd that happen? It can't happen. Something's not equal. And so even though I wrote this equation, it doesn't make sense yet. And here's what we have to do. Look down here. You're going to learn, I'll show you this trick. I'll show you how to do it. You're going to put these numbers in front of certain things. And they're called, what do they call those numbers in math? If I said x to the third power, and I put a 4 here, that's called an exponent. What do math people call the number in front? What's that fancy word they name the number in front of x to the third? Starts with C. Coefficient. And guess what they call it in chemistry? Coefficient. You're going to learn how to balance an equation. Now look what happens here. Look at my drawing here. One Zn, one zinc will react with, it won't react with one HCl. It won't. Well, what if you had two HCls? Look, HCl, HCl. That's two HCls, isn't it? Now, can you take these apart and rearrange them and make that? Let's take a look. Rearrange. Can I take one of those and attach it to two of those? Yes. And I have two of these? Yes. Now it makes sense, doesn't it? This is called a balanced equation. This one is balanced. Now, when I was your age, the only thing I ever heard about balanced was like this kind of stuff, right? Balance on one foot. But as you get older, guess what I found out the word balance meant to people in the business world? What did it mean in the business world to balance something? And if you have a checking account? Cool, okay. When you guys learn about money, do you have a checking account? Okay, now, do you ever look at the letters that the bank sends to you every month? Or do your parents do that?
I look at it, not really.
Okay, you should. But here's what happens, okay? So let's say Luke puts in $500 into his bank account. And he then, do you have a credit card?
Yeah.
Okay. So then let's say in his credit card, which is tied to that account, he spends $50 and another $50, and he spent $100. And that's all he spent for the month. The bank sends him a statement that says, you started with $500. You spent 50, you spent 50, and the bank says you have how much left over? It better say what? It better say you have how much money left over. You had 500, you spent 50 and 50. They better say 400. You know what? If they don't say 400, something's out of balance. Balancing simply means keep track of every dollar. In chemistry, keep track of every atom. If you ended up with 2 chlorine atoms, you better start out with 2 chlorine atoms, and I did. You got it? You can't create something out of nothing. It's called the law of conservation of matter. You can't say, I'm going to start with 1 chlorine atom and end with 2. How'd you do that? You can't. All right, so anyway, that's enough of that for right now. I'm going to skip this right here, and I'll do driving forces a little bit later. Hey, did you take an exam today? That's why you're looking tired, right? Are you looking tired? You kind of tired? What kind of exams did you take? Math? Foreign language? Ooh. You must be tired. You don't have to listen to me if you don't want to then, okay? But anyway, what we're doing is, what we're doing, even if it's on video, I'll review everything I'm doing today. Everything I'll do today, I'm doing tomorrow, okay? Got that? So if you're out of it today, just relax. Just relax a little bit. Let's turn the page now. All right, here we go. Remember, you're trying to do your very best in here, and you said, what keeps me from doing my very best? All right, you know what humans like to do? They love to name things, and they love to put things in categories, don't they? They love it. How about music? How many categories of music do we have? Don't we have categories? And we have categories of everything. if you were a car person, but they have a name for every car part you can think of. All right, let's take a look. So humans are good at putting things in groups. That's what classifying means. For 10th grade chemistry, all I want you to know is these 5. There are 5 kinds of reactions that I'd like you to know for first year chemistry. Let's take a look at them. Ready? The first one's called synthesis. Okay? The first one's called synthesis, and it looks like this. Some material, A, plus another material react, and they form one material. Whoa. 1 plus 1 equals 1. One material plus another material equals, so what do they do? Didn't they come together? That's a fancy word. I think every one of you should know that word. It's called synthesis. Synthesis means to bind together. And that's why they call it a synthesis reaction, because A plus B yields AB. Are you with me? There are some chemical reactions, you start with 2 different chemicals, and when you get done, you end up with 1. And that's called a synthesis reaction. All right, let's go down here. What is the opposite of putting a chemical together, putting 2 chemicals together, is decomposition. That should be DEC. Anyway, decomposition. Decompose. Now look at this. AB, that's one chemical, breaks down into A and B. Is this almost too simple? Okay, I'll get to the hard parts, but I want to make sure we get the simple parts first. So we have synthesis and decomposition. Now let's see how smart you are. I want you to go down here, this page right here. I want you to look for any of those reactions and tell me whether or not you think it might be a synthesis or it might be a decomposition. Which of those look like synthesis or decomposition? What do you think? Do any of them kind of, hey, which one?
Number 3.
All right, what do you think it is? All right, take a look. A plus B yields AB. Very, very good. Anybody else find a synthesis or a decomposition?
Number 6.
Okay, 6. Look at this. A plus B yields the chemical AB. See, you guys are you can do well in this chapter. You can. A little bit of work and you can do well. Any other synthesis you see? All right, how about decomposition? Do you see any decomposition? All right, let's turn the page. Do you see any synthesis or decomposition on this page? If you want one of these papers, I have one right there. I think it's on the table there. But I thought, even if you don't feel like doing anything today, oh wait, do you see an extra one? Oh wait, here they are. I have them with me. Sure. If you don't feel like doing anything, I'll do all this tomorrow, okay? I'll do all this tomorrow. Anybody see one? Raise your hand if you think, how you answer. Yes.
Number 1.
What do you call that?
Synthesis.
I would too. Okay, anybody else see a synthesis or a decomposition? Somebody new, yes. Gabe,
Number 4.
what you got?
Synthesis.
Yes. All right, any other synthesis or decomposition? Yes, Matthew.
Number 2.
What do you think that is? And you know what the giveaway is? A decomposition, how many reactants do you see? Only one. That's the only one you're going to find. Decomposition, you start with one reactant, and it breaks up. Any other synthesis or decomposition? Yes, Charlotte.
Number 9 is decomposition.
9 is decomposition. All right, I see at least one more. You already answered one. You answered one. Anybody hadn't answered one yet? Aiden, you haven't answered one yet. Good. Any other synthesis or decomposition? No? Anybody else? Yes. And what do you call it? Yes. Hey, if she can take 2 exams, Aiden, if she can take 2 exams and answer that question, you should be able to answer, couldn't you? Okay. All right, let's flip it over. Let's flip it back now. I thought we'd do two at a time, just kind of make it not so hard. But now let's look at the next one. This also is a kind of common in chemistry. Look what happened here. A plus BC yields AC plus B. Are you okay with me using these letters instead of drawing hearts and stuff like that? Okay, I'd rather do that. So, uh-oh. What? What? I didn't do anything. What? What happened? Oh, that's weird. Okay, maybe went to sleep. Computer went to sleep. All right. Okay. All right, so let's take a look now. What do you think? And I'll tell you what. Let me see if I have any money with me. I'm gonna give away $1 today. I went to a restaurant yesterday. It's a pickup, a carry out, but I did give $1 tip. So, ooh, I have another one left. Okay, I have $1. All right. Anybody who can tell me right here, A plus BC yields AC plus B. Do you think that A is more likely to be a metal or a non-metal, and tell me why you think that? So just, I'll answer, as many people want to answer, you be the first person to answer and you get the $1. Do you think A is more likely to be a metal or a non-metal, and then you have to explain your answer to get the $1? Now you can't lose, nobody else has their hand up, so even if you get it wrong, you can't lose. You want to try it, Zach? Okay. All right, Matthew.
Wait, do I get the $1 if I get it right?
If you explain, yes. Is A more likely to be a metal or non-metal, and what's your rationale?
Non-metal. Because
I'm listening.
because if it was a metal, it would be like what non-metals like together, it would break it down, so more likely to be a non-metal.
Okay, I'm going to say no, all right? But somebody else can take a chance. Yes?
I'd say metal because it was able to like add together with like the D and everything.
Because what?
Because it was able to like be together with the D and could be with the B and then be with the D like add together. So that would be like a metal.
Say that one more time, a little bit louder.
It would be a metal because like it was able to be together with the D and also even the D like and metals can like be together.
Metals like to be together? So you think A and C are both metals? Okay. All right, I'm going to say no, but I did listen to you a little bit longer than Matthew. That might give you a hint. Yes?
Metal because positive charge in the front, and it's usually metal to have positive charges.
Keep going. Oh, that's it? You're getting closer. You didn't quite get it for me. Anybody else? Anybody else want to try it? Yes?
A metal because it's A plus B, and whenever they're together, the metal always comes first.
First in what?
Like when they're together.
When they're what now?
I don't know.
Is that because the alphabet A comes before?
Like whenever they're together and you're making a formula.
Uh-huh.
The metal comes first.
That's true. That is true. And so, do you think, did A kicked out B, didn't it? Did A kick out B? So you think A is more likely a metal. What about B?
Non-metal.
Why is that?
Because it's wait, are we talking about which one are we talking about?
You said A was more likely a metal because when you write a formula, the metals are written first, and that's why you thought A was a metal. What do you think B was?
It's probably I don't know. I'd probably say metal too,
Because
because in this in the second example for it, it's
well, don't look at that yet. Don't look at that. Just look at this one.
Oh,
Or you keep switching?
It'll be a 30.
You keep switching on me.
It would be a not. No, wait, what would I say was last?
I'm gonna give you $1 because you did answer my question was A, what makes you think A is a metal? Because when it formed a compound, it was written first, and the metals are written first. So here you go. Come pick it up. Now, guess what? I don't know why you couldn't answer the next part of the question, because who's written first here? B or C?
B.
So what do you think B is then?
Non-metal.
No, you just told
I
me.
mean a metal.
You just told me A was written. That's what made A a metal, didn't you?
Yeah.
Okay.
But I meant to say non-metal.
All right. Now this one I don't have any more dollars. Sorry. Look at the next one. D plus BC yields BD plus C. What's happened to the alphabet? No, it's not an alphabet thing, is it? What do you think's happening here? Anybody? I don't have $1. Sorry, I don't have any more dollars. Anybody? Here, a metal kicked out a metal. See that? And took its place. What do you think's happening here? Look at it. What do you think? Matthew, help me out. Why is D written second here?
Because it's a metal.
You just told me that A was written first because metals are written first. That's why I gave you the $1. Wait, which one's written? Why is D written second?
Because it's a non-metal.
Okay. So what do you think D is more likely to be? What do you think? That's a non-metal. So here, guess what? Metals like to kick out metals, but non-metals like to kick out who? Non-metals. Get that? So let's take a look here. I want you to see if you can find me a single replacement reaction. Got about 3 or 4 minutes, right? Find one of these that look like it's a single replacement reaction and tell me whether it's a metal kicking out a metal or a non-metal kicking out a non-metal. All right, who hasn't had their hand up yet? Taylor, you haven't had your... What do you think? Which one looks like a single replacement? Eight? Okay, take a look here. This is kind of an unusual one. I'm gonna skip number 8. I'm gonna do that later. What do you think about number 5? Now, even though hydrogen is not a real metal, it acts a little like a metal here because it acts like a +1 and -1. Remember that? So guess what zinc's going to do? Zinc's going to kick out the hydrogen and form zinc chloride. Yes, no? So this one is single replacement. Okay, now what's right here? Let's do this guy right here. What if I told you? Is everybody still with me? What if I told you it was single replacement? Who would he kick out? Who would the aluminum kick out? Would he kick out the sulfate or kick out the copper? Metals kick out metals. So guess what? Aluminum is going to kick out the copper, and you're going to do this experiment, by the way, and it's going to form a compound with sulfate. Now, remember how we first started this lesson? You thought, oh, this is so easy. This is so easy. Can I show you something here? You cannot do this. You cannot put AlSO4. We just had an entire chapter and a retest. How does aluminum form a compound with sulfur? What's the charge of aluminum in a compound? Look at the periodic table. What's the charge of aluminum in a compound? Isn't it one of the always metals? What is it? +3. And what's the charge on sulfate? I know you didn't memorize those yet, did you? Anybody know sulfate's charge? -2. Now what are we going to do about that? What are you going to do about the fact that you're +3 and you're -2? You know, you're very good at this. How many aluminiums do I need? 2. And how many sulfates do I need? 3. Isn't that right? See that? So it did kick out copper. It did. And it formed a compound with sulfate the way it always does. Now later, tomorrow, this should bother you. You know why it bothers you? Because how many aluminums are on the right side of the arrow right now? How many aluminums do you see on the right side of the arrow? Is that little guy there? What's that mean? What's AL2 mean? 2 aluminums, right? How many over here? You know what you're going to do tomorrow? You're going to balance. You're going to put 2 there. Now watch this. How many sulfates are on the right side of the arrow? Look at my fist. That's a sulfate. How many sulfates are on this side of the arrow? 3, but how many are here? Don't say 4. 1. 3 sulfates. 3. But wait a minute. How many coppers is that? How many? Oh yeah. That's what we're going to do tomorrow. We're going to learn how to balance equations, okay? Hey, thank you very much. Again, anybody who is taking an exam, you don't have any makeup work, everything I did today, I'm going to redo tomorrow, okay? When you guys are a little bit more